Weak bases are materials that react with water to produce the hydroxide ion. And we'll give it a generic example of a weak base. The base abstracts one of the protons from water and produces Hb plus and OH minus. And you can write an equilibrium expression for this kind of generic reaction. Because water is a liquid, it doesn't show up in the equilibrium expression. And you have an equilibrium expression with an equilibrium constant that's given the symbol Kb. And Kb is kind of like a Ka, in that it conveys how strong the base is. But unlike a Ka, it can't really refer to the ionization of the base like a Ka refers to the ionization of an acid, or at least not in quite the same way. Instead, the Kb measures only the extent to which a base reacts with water. And there are two main types of weak base. Those are the two types of base are a neutral material with a lone pair of electrons that can accept a proton, and anions of weak acids that also have lone pairs of electrons that can accept a proton. The neutral structures are often, but not always, nitrogen-based. A lot of nitrogen or amine-based structures have a lone pair of electrons that can accept a proton. As for the anions of weak acids, these are negatively charged materials, and to become negatively charged, there's generally a lone pair of electrons. Now, calculations with weak bases are almost identical to those with other equilibrium reactions, like those of weak acids. You just need to remember that your reaction needs to include water as the source of the hydroxide ion. So if you know the initial concentration of your weak base, in this case the hypochlorite ion, you can work out the equilibrium concentrations of hypochlorite, hypochloric acid, and OH minus. To find the equilibrium concentrations, all you need is the Kb for the anion.